Hello everyone and welcome. This is your teacher Inas Shabani from the Department of Physics, Exact Science faculty from the University of Constantinople. In this video, we will study the hydrostatic pressure force acting on a submerged surface using the hydrostatic pressure apparatus. So by the end of this practical work, we will be able to determine the hydrostatic force experimentally, calculate it theoretically, compare both values, and at the end evaluate the experimental error. So as an introduction for this practical work, let's start with the definition of hydrostatic pressure. Hydrostatic pressure is the pressure exerted by a fluid at rest. So unlike atmospheric pressure, this pressure increases with depth because of the weight of the fluid above. As a result, a submerged surface is subjected to a resultant force known as the hydrostatic pressure. So, before starting the experiment, the students will be tested on their prerequisites by answering, for example, questions like what is pressure, what does density describe, what creates a moment, and when is a body in static equilibrium. To have an idea on let's say thermophysical properties, forces, equilibrium, etc. So, this is the most important part of the practical work, which is the description of the experimental procedure. So the apparatus here consists of a transparent water tank containing a blue quadrant, as you can see in the figure here, connected to a horizontal balancing beam. As water is added to the tank, the pressure acting on the vertical surface of the quadrant increases. This pressure produces a hydrostatic force, which creates a moment about the pivot and causes the beam to rotate. To restore equilibrium, calibrated masses are placed on the opposite side of the beam, on the left as you can see, and the moment generated by these masses balances the moment produced by the hydrostatic force. Once equilibrium is restored, the corresponding submerged depth is measured, and this procedure is repeated for different water levels, allowing the hydrostatic force to be determined experimentally. Moving on to the theoretical part of the practical work. So, the hydrostatic force here can be determined using two different approaches that will be shown later on, but as you can see here, we can see all the forces that I just mentioned drawn and in a perfect way, in which we can see the quadrant here, the forces of the moment. We can see also the force of the gravitational force of the masses. Here is the Fp, which is the hydrostatic force exerted by water on the vertical plate, which here is the representation of this plate. And this is the most important part, as later on the depth of the water, here represented as D, let's say consists of the submerged part of the vertical plate underwater. So, later on, or in this slide, we can see or we can compare how to calculate experimental hydrostatic force and the theoretical hydrostatic force. So here, as I mentioned, we have two different approaches for the experimental and the theoretical one. So in the case of equilibrium between the hydrostatic force and the gravitational force of the masses, here is the equation or the expression which dictates the equilibrium. And from this equation, we can calculate the experimental force. And then the gravitational force, of course, is related to the mass times the gravitational or the gravity in general. And HP here is calculated by two different methods. Why? Because in this practical procedure, we will be doing two tests. The first one is when the water is filled. We fill the apparatus with water and we add masses so that the vertical plate is submerged. And for the second part, we actually remove the water and the masses, and also we're gonna calculate or measure actually the D, or the submerged surface height. Same thing for the theoretical hydrostatic force. Here is the expression of the theoretical hydrostatic force. Here we need the H, two different expressions, of course, for the fill-in water part and for the removal water part. And of course, the surface is calculated as follows. Moving on to the student's task. So after understanding the practical work technique and how it works, the students will be asked to measure LG, which is the pivot length, H, which is the quadrant height, D, which is the vertical plate height, and B, which is the vertical plate width, which will be needed, as we just saw, to calculate the experimental and theoretical force. When it comes to the work itself, the work, as I mentioned, is divided to two parts or two phases. Phase 1, the students will be adding water and masses by respecting equilibrium. And after equilibrium is respected, they will be measuring D, which is the submerged surface height, and then a repetition of the experiment until the vertical plate is fully submerged. Once this experiment is done, we'll be moving on to phase 2, which is water and masses removal by respecting, of course, equilibrium. We'll be again measuring D and repeating the experiment until the vertical plate is no longer submerged. This practical work is, let's say, divided into two practical works, actually, to allow the students to see how adding water and removing water affects the error margin, because at the end this is the same, we're repeating the same experiment, but here we're repeating it to actually get an insight on the error margin of the experiment, of course. Moving on to the report making, so after completing the experiment, the experimental hydrostatic force is calculated and the theoretical force is obtained from the equation. So by obtaining both these values, the students are asked to plot them. They will be plotting the experimental force versus the theoretic force in the same graph, and so both results are plotted on the same graph for comparison. They're gonna be discussing and interpreting the graphs. Of course, finally, the percentage error is determined and the possible sources of discrepancy between theory and experiment are discussed in the report, of course. Moving on to the learning outcomes. So this practical work provides a clear understanding of hydrostatic pressure and the force it generates on submerged surfaces. So it also illustrates the importance of static equilibrium in experimental measurements and highlights the relationship between theoretical analysis and experimental observations. So at the end, this practical work develops practical skills in data analysis, graphical representation, Excel, Microsoft use, and the scientific reporting, of course. So, at the end, I thank you for your attention. If you find this video helpful, or if you have any questions, don't forget to contact me via my email already mentioned in the first slide. Again, thank you for your attention. Bye-bye.